Buchanan, and I'm Director of Technology here at PETRONAS Canada. And I'm actually a leader within our company for carbon capture and our new company that we're looking to start up called Carbon Strike. By far the biggest one is the cost and cost certainty. We knew what it would cost us to build these things. We knew where the trouble areas were. And so we sat down and we started to work backwards towards a solution. And we did workshops and rethought the whole thing. We needed to produce something that didn't look like a gas plant with big columns, thick walls of stainless steel. We were doing post-combustion at such low pressures with fans, and yet we were still building these massive towers. And they're thick walls because they have to support these towers. And we said, we need to be more like the boiler industry. We need to be closer to HVAC or farming. So we started looking to get inspiration from these industries. Second thing was we needed to be modular. We needed to be shippable. The biggest cost for these large facilities, once you get into these sizes, is field labor. And it's very inefficient, very costly. How do we get rid of this big ducting, the large vessels, all that type of stuff? And then we also were floored by how much stainless steel welding, which is where the real costs are. And so how do we get those costs down? Thirdly, we weren't paying enough attention to the cost of the back end of the unit. Basically, where we compress the CO2, and that's where a lot of your power is. That's where a lot of your stainless steel is. So we said that's something we need to focus on. And basically, we needed to have something that produced CO2 out of the capture unit much higher than the 100 kPa. We need orders of magnitude. And lastly, we needed a solvent that did not degrade as fast. Ideally, didn't need a reclaimer at all, because we faced the reality that post-combustion is nasty. You've got O2 in there, you've got NO2, you've got SOx, everything that solvents hate. And so we needed to come up with a solvent that was more robust. We want to basically be upfront with everybody. And that's why we call it CO True. We started with this blank slate concept, and we came up with a solution that actually can get us through our gates. And so by far, the biggest thing that we can do is to help our peers and in industry. We need to get more of carbon capture out there. And the only way you can do it is by getting the cost down. Not just about the technology, but how we build it as well. The first thing was our new solvent. We filed for a patent on it that we call CO True Solve. And we can produce CO2 at 500 kPa. That doesn't sound like a big deal, but this is 5 times higher. This is orders of magnitude higher pressure. And so what that means, the lowest pressure you come in with really sets the size of the compressor. That's where your expensive stuff is. It's all big that has to handle the low pressure. And so we basically cut these costs in half. Basically 2 compressor stages for us, which also means much lower power. By the way, we've been running the solvent since March. And what we found is that this solvent, we leaned into things that the other vendors are shying away. And the degradation is so low that we haven't had to run our reclaimer. It really gave us the inspiration to say, okay, we can eliminate the reclaimer once a year or something like that. But we don't have to install a permanent one, which got those hidden costs down, like you mentioned earlier. The other thing is our colleagues in Malaysia were working on membranes as a contactor. They have a patented process they've been developing in their research center. And what I love about it is we've got 1,000 hours running these membranes, by the way. But to think of it's not like a traditional membrane where you're pressing the CO2 with osmotic pressure across a membrane. What we're using the membrane for is the really small pore sizes. So it's like packing more packing, like structured packing, into a much smaller compact thing. So when you go out to our site, you'll see this 130-foot tall tower. Inside that tower is about 80 feet of packing. So by putting in these membranes, we shrink that packing down from 60 to 80 feet to 4 to 6 feet. So it's another order of magnitude change. The other thing that the membranes do is it prevents direct contact, which reduces all of these side reactions that are actually slower that degrade the solvent. So the combination of the new solvent and these membranes is what we're testing now at our site at commercial scale. And it's working brilliantly. In fact, we just reached a milestone of 1,000 hours, well over 90% recovery. And then we said, okay, we've got these membranes and this new solvent. We need to get the cost down of the absorber. We got to get rid of ducting. So we came up with a solution that's called the box contactor that we've also got patent filed for. So no more towers. We've combined all of those towers, all those vessels into one box. And inside the box, we've also put the pumps, the blowers, the piping, the cable tray. So basically, if you want to think of it, is we've taken the pipe rack and we've turned it into a process unit. It's not just Canada, we're an international company. So we're looking at a long-term business for us. I want you to think of these membrane boxes as being like Lego bricks. So inside we have lots of these cartridges that we can extend depending on how much carbon you have, how much gas you have. So the only limit is really how big of a module can you ship to your site. So what does that window, that envelope look like? We've been working with a few customers and we just completed a layout and a design for 2,400 ton per day unit. So that's almost a megaton per year, right? So, and we built that in 3 800 ton per day boxes. We could go probably up to 1,000 with their shipping window. That's pretty amazing. And it's all integrated. So you just drop it in. There's no stick building or anything like that. And the beauty of doing it in 3 was we were able to fit them right next to the sources of the CO2. And when you put it right next to the source, it means that you don't have that big ducting to ship. And because they look like an HRSG, they look like a boiler and still 100% modular, 100% shippable. That's the kind of thing that can scale. It's rethinking how you build these facilities, even in the shop. And that's the way you scale up carbon capture, is you're able to mass produce them. Everything's basically made of sheet metal. Sheet metal is a lot easier to work with. Off-the-shelf structural steel is much easier to work with than building bespoke vessels. Really looking forward to this year is really talking to some potential customers, my peers that are out there, end users of the technology. I'm also interested to find a first customer. We're of course developing it for ourselves, but we're always interested to see what others think of it. I'm also presenting at the conference, so our technology and our journey. I'm really looking forward to getting feedback.